All right, this is the video, the second part of the video for lesson 1 of Math Models Unit 3. I wanted to find the best calculator for this, so I went and found one that will give us a equation from 2 points. So let me show you how it's done. So we've got, they want us to find the equation of this function here, and they want us to find it in 2 different ways. We're going to focus on finding it in slope-intercept first, and then we'll talk about how to get the other ones from that. So we are going to start by going here to the link in the video description, and it's linear regression, which means it's going to take the points and find the line that goes with those points. So I've already went ahead and put these points in, 0, 3, and 1, 5. And I put them in as x and y, so 0, 3, and 1, 5. And so what I'm going to be doing is, once I type those in, it's going to give me this line right here. And more than that, it's going to give me the values for the m and the b. And if you remember, the m is the slope, and the b is the y-intercept. So let's jump over here. So we know then that my equation is y equals 2x plus 3. So that's going to be answer choice B for slope-intercept form. So our slope-intercept form is the one that has that arrangement. So then it asks for point-slope form. Well, I'll tell you right now, point-slope form is going to be the one that is not in slope-intercept form. So you notice how it says y minus 3 equals 2x? That's point-slope form. That's easy because it's only one option that looks like that. So that's going to be that one. And then our slope, of course, is our m from over here. So our m is 2. And so that would be answer choice D. So in all of these, you're going to put the values for these points in and go through that same exact process, finding the correct values for the different equations using the method that we just talked about. And that's how you're going to do the rest of these until you get to number 9. Once you get to number 9, they don't have an equation for you, so you've got to use some concept understanding to get these. So let's talk through a little bit of this. Find the slope, then select the equation slope-intercept form. Well, some of these are going to be weird ones, and they've done that on purpose. They wanted to make sure you understand these kind of special cases for slope. And one is when it's a horizontal or vertical line. If it's a horizontal line, it means that the slope is 0. And if it's a vertical line, then the slope would be what we call undefined. So we can see right here that the slope is 0, and that's that flat line. There is no slope. There's no increase or decrease on that line. And then the y-intercept is easy to find. It's the point right here, right there. And that is going to be, oh, that's wrong. It should be positive 4. So I'm going to select negative 4, even though I'm pretty sure that that's a mistake, and we'll just see what happens. And don't worry about missing that question if it happens to be wrong on your thing. Okay, next one. Same idea. I'm not going to even walk through this one. Same exact idea. You can see that that's a 0 slope. Find the slope, then select, again, same idea. So we know the y-intercept, that's the easy one to find. The y-intercept is 0. And then my slope is just going to be, again, we do rise over run. So we go up 1 over 1. Up 1 over 1. So that's 1 divided by 1. Rise over run. And so then my slope will be 1, because 1 divided by 1 is 1. This is an example of undefined, and it does not have a y-intercept. Let's just mark that. Undefined slope. No y-intercept. And that's all you have to do on those, because these do not cross the y-axis and they don't have a slope that is defined. So this is going to be some word problems from here on out. And the word problems here are going to be more or less you putting things where they belong in the equation. So let's kind of like talk through this. A car decreases in value as it gets older. Write the equation to model a car's decreasing value if it initially cost $22,497 and was valued at $18,497 after 2 years. The variable will be the number of years of the car's age, the y-intercept will be the initial cost, and the slope will be the rate that the car is decreasing in value in dollars per year. So let's talk about this. We already know easily what the y-intercept is going to be, the initial cost. So the y-intercept is $22,497. So before I even move into this, I already can see that between my two equations that I'm given, only choice D makes sense as the correct equation because it has a y-intercept of 22,497, and they told us the initial cost was the y-intercept. So that's got to be this value. And then we see that there's a negative 2,000, blah, blah, blah. So this is now an equation that I can actually go type into my calculator. So let's go ahead and do that. Go to Desmos and open my graphing calculator. And even though the equation is not in X and Y, I'm going to treat V and T as if it was X and Y. Actually, now that I'm looking at this, I think that we can get this answer without even doing that. What's the value of the car in 10 years? So you'll notice the value of the car after 2 years already was $18,000. It's already gone down $4,000 in 2 years. So clearly E cannot be the answer. The value of the car will have gone down much, much more than that. And so it has to be C. Just common sense. All right. So I'm going to scroll down here. Very similar concept here. I'm going to let you work on that one on your own. I think you'll be able to get it. Use the same basic concepts that we talked about in this problem. Same thing with number 15. Remember, there's always going to be something that is per hour, per year, per month, and there's going to be something that's a fixed cost or like a starting number. That's always going to be the y-intercept, and the per hour, per minute, that's going to be your slope. Keep that in mind. Lastly, we have another question where we're given 2 points and you select the equation. You need to use the same method we used above on questions 5, 6, 7, and 8. So plug in those 2 points into the linear regression graph and get the M and B values for those.